Right. So hopefully this will pick up what I'm saying. I don't think that should not won't come out on the thing, I think. And this is just the areas that are going to be covered by the test. I think, just to be clear, this is the upcoming chemistry test. It's chapters 13, 14 and 15. 13, 14 and 15, which means that it's 13 and 14 just acids and bases, and 15 is the stoichiometry one. Stoic. Okay, so that might not have been clear on some of the things, but they're the 3 chapters, and these are the areas, I guess. So defining acids and bases, just being clear what they are, what the definitions. Talking about that acids donate a proton, a hydrogen ion, and bases accept a proton or a hydrogen ion. They have certain properties. Acids have this sour taste. Bases have a bitter taste. There's a soapy feel, the bases, and acids are corrosive. So those basic definitions, good to know. And then the 6 types of acid reactions, you should also know. So they're the ones that are listed. All those, for example, things like the neutralisation reaction is one. Reaction with the carbonates, another. Reaction with metals, another. So just being able to say what the products would be, okay, and which would give you a start on writing the equation. So if you can at least say what they are, and then from given the reactants, you can make a prediction then what the products would be, write the formula, and then also write the balanced equation ultimately. Okay. So anyway, there are 6 of those. Knowing these definitions for acids, monoprotic. Do we know that one? All good, yes, all good. So it's talking about proton as in the hydrogen. That's just another word for proton's just another word for the hydrogen ion, and if mono meaning one, so it can give 1 hydrogen ion. So hydrochloric acid is an example of that, just HCl can give 1 hydrogen. Di means 2, so diprotic would mean an acid that can give 2 hydrogens. So sulfuric acid, there aren't many examples, but sulfuric acid is probably the example, H2SO4. And then amphiprotic, do you remember what that meant? Amphi?
They can give both acids and bases.
In a way, they can both, yes, they can both give a hydrogen and accept a hydrogen. So yes, and probably there's again not a lot of examples. There's probably 2 examples I can think of. Is HSO4 minus. That's an ion that has already got a hydrogen, so it's able to give that like an acid to become SO4 2 minus, or it can accept a hydrogen and become H2SO4. So it can go either way from that one starting point. Another good example is water. So H2O, it can give a hydrogen to become OH minus, so acting like an acid and giving it, or it can accept a hydrogen to become H3O plus. And so you'd say water is an amphiprotic acid. Actually, probably don't often use that term for water, but by definition it is. And so that also relates to the conjugate acid, so that things can act as acids or bases, and they always form pairs, and they just differ by a single hydrogen. Okay, so those examples we just gave are good examples of one being the conjugate base or the conjugate acid of another pair. Okay. Now you need to be able to identify them. So if you're given a reaction, products and reactants, you need to be able to label and say this is a pair and draw like a connecting line from a reactant to a product. This is the pair that's an acid-base pair. This one's acting as the acid, label it acid, because it has the extra hydrogen, and this is just the same thing minus the hydrogen, that's the base. And usually in reactions there'll be, if they are acid-base reactions, there'll be 2 pairs. And you'll be able to connect those together and say which one's acting as the acid, which one's acting as the base. So we're happy with that stuff? I'll just keep going, and then I guess if you've got any questions we'll come back. And then just have some idea of these formulas, okay, these pH and other formulas. So the main one is that pH is minus log of the hydrogen or hydronium ion concentration. So that's in moles per litre or molar. And also being able to turn that around. Okay, so this works if you work out the concentration of hydrogen ions, or hydronium ions, you just take the log of that and negative of that answer, that gives you the pH. But if you're given a pH, can you then work backwards? So knowing your way around your calculator, and so if you're given a pH, how do you work backwards? Well, you'd make that negative, whatever it is, and then you take the inverse log. So you need to know how to find that on your calculator. Okay. I've just written second function log here, but that just depends on what you've got. So you just need to be clear about how to do that. So it's a good idea if you're working out a pH and you get one, can you work backwards? Can you do those keys in reverse to get back to the hydrogen ion concentration? Okay. Similarly, the other formula you need is this, it's the ionic product of water, it's sometimes called. It's just multiplying the concentration of hydronium ions by the concentration of hydroxide equals a constant, 10 to the minus 14. But being able to use that, so if you had to work out the hydrogen ion concentration and you only had hydroxide, just being able to, inverting that formula, rearranging the formula to say 10 to the minus 14 divided by concentration of hydroxide will give you that. And usually the reason you want to do that is so that you can plug it into this formula to work out the pH. Okay, and then also just being familiar with these formulas, our mole formulas, N equals M on M, C equals N on V, and also some idea of how to use this dilution formula, which basically says the number of moles at the start is the same as the number of moles at the end, or the concentration times the volume equals the concentration times the volume. Being able to use that. Okay, what else? So just generally, stoichiometry then. All the stuff we've been talking about, balanced equations, the 3 steps that you have a known, that you know something about its mass or its concentration, convert that to moles, and that's sort of step 1, translating to moles, and then step 2 is using your mole ratios based on your balanced chemical equation to work out the number of moles of your unknown, okay, and then step 3, converting that unknown mole, whatever it is, into whatever you've been asked for, grams or concentration or volume, whatever the question asked for. Okay, so that's your basic principle of stoichiometry. And all the things we've been doing for the SAC, the titration, procedures, glassware, rinsing, all those, don't forget those kind of calculations you do for using the idea of concordant, using a concordant results for your average of your titers, and whatever. What else is there? Standard solution. Standard solution for setting up your titration, and being able to write full reactions as part of all of this, and also what ionic reactions are. So that's the overview. So it's really, if you've got any questions, I'm happy to have a go at answering them. Yes, Steve.
Sorry, could we do a couple of
pH examples? Okay, sure. Did you have any ones in mind? Oh, actually, what about that sheet, the booklet? Oh, okay, yep, all right. So there were worksheets that we handed out. There were some pH ones there just for, where were they? Worksheet 31. There's a few. I'll just write them on the board, but so. Hang on, let's go just... Okay, so let me have a think. Were any particular ones there? Let's see. Determine the pH of a solution. Identify whether it's an acid or a base. Determine whether it accepts 1 or 2 protons or ionize. Follow the steps outlined in the table. Okay, so here's a question. Determine the pH of pH of this is 1C. Sorry, question 1C. 0.10 molar sulfuric acid. 0.10 molar H2SO4. Okay. So the first thing you need for pH, well, the last thing you need, what you're looking for is the concentration of hydrogen ions. Okay. So you need to work out. So this is really the thing that you're interested in. What's the concentration of hydrogen? Now the key point here is that there's, for every 1 molecule of sulfuric acid, there are actually 2 ions of hydrogen, 2 protons, 2 hydrogen. It's diprotic, this one. So, in other words, when you have a concentration of 0.10 molar sulfuric acid, it will break apart to give you double the concentration of hydrogen ions. So from that, you can say that the concentration of hydrogen ions equals 2 lots, double the concentration of the molecule of sulfuric acid. Okay? So it's 0.1 mole. So that equals 0.2. That's the kind of trick to these pH questions, just understanding what the exact concentration is you're dealing with. Okay, so the first question, following the workbook, the first question was identify whether the substance is acid or base. It's an acid. Okay, part 2, determine whether it accepts 1, 2 or 3 protons. Donates them, and in fact there are 2, we've discussed that, so that's why there's 2. And then we can work out the pH. Right, so pH equals minus log of the concentration, so 0.2. Now I'm going to be in trouble because I don't have my scientific calculator. Anyone got a scientific calculator handy? Oh, good, yep, it's done. Sorry? 0.6989700. How about 2 decimal places?
Okay. 0.70.
Ah, that's better. Yeah. Is that what we all got? Yep. Okay, good. Oh, thank you. So that's fairly straightforward. Okay, what's a more tricky one you might get? D. That's it. So you don't have any hydrogen ions actually, obviously here. So again, it's the same concentration, is it? No, not quite. But it's calcium hydroxide. Okay. And so this is a base. It's got hydroxide, and it's going to generate 2 hydroxide ions for every 1 molecule of calcium hydroxide. So the concentration of hydroxide equals 2, same kind of idea as the acid, of this concentration, O1, oops, what's going on there? 0.10 molar, 0.020 molar. Okay. Now, we don't have what we need for our pH formula, so we need to use that second relationship, the ionic product of water times H3O, or H plus, sorry, I flip between those two, it's 10 to the minus 14. So H3O plus, I'll just rearrange that formula, minus 14 over the hydroxide, so 0.020. And then we need to work that out, don't we? Oh. Okay, let's see if I can do this. So it's divided by 0.02. equals 5 by 10 to the minus 13 molar. Okay. And then we put that into the formula. So pH equals minus log of 5 by 10 to the minus 13. Log 5 13 minus. Oh, good. Okay, so 12.3 I've got. Do we agree? Good. All right, good. So that's the extra step with if you only got a base rather than a. Actually, that's got a few things in it, so that actually covers quite a lot of ground. And then the only other thing. Another example might be working that idea of working backwards. I'm just not sure how I find my way around this calculator. Anyway, let's see if we can do it. We'll have a go. So, if you've been given a concentration, a pH, and you have to work out the concentration. So that might be like, say, 2C. So pH equals 1.0, and it's a you want to find out the concentration of H2SO4. All right, that's the question. All right, so that's the answer. So we have to now think, how do we get back from that? So in other words, 1.0 equals minus log of our hydrogen ion concentration. Okay. So in other words, 10 to the power of the negative pH. Okay, so you can write it around, or you can write it that way. That helps. 3O plus equals 10 to the minus pH. It's a funny way of writing it, but they can do that. Okay, equals 10 to the minus 1. Done, actually, isn't it? Equals 0.1. Yeah.
When I tried to make the second answer, sorry.
Yeah, I know. I was trying to think, how do I do that on the calculator? But that's.
I'm sorry, what is it?
It's not log. No, it's not log. It's 10 to the power of. Sorry, it's not. It's not ln. All right, so you make it negative, -1, and then you have to do the inverse log is just 10 to the power of.
Oh, okay.
So you'll see that when you press second function log, it's just got 10 to the power of. So you do that, 10 to the power of, and then you put your -1 in that place. So 1 minus, I think, and then 0.1. Okay, so you can press.
What buttons you pressed?
So what I did on my Sharp EL 531WH calculator was, for those listening at home, I pressed second function, which is the big orange button up top left, and then I pressed log, and then I pressed the minus, the plus minus button. You get the minus, and then I press 1. Okay. Yeah, that's right. And what I saw on the screen was 10 hat brackets -1. And when I pressed equals, I got 0.1. Okay? You just need to do it a couple of times. It's not that hard. It just looks messy. So hang on. So that's the concentration of hydrogen ions. And the trick is that there are two. So if they're asking for the concentration of the sulfuric acid, it's actually going to be half that, because we remember we continue to work backwards. So it's 0.1 molar equals the hydrogen ion. I keep saying hydrogen, hydronium, I just use them interchangeably, but just one hydrogen. the concentration of hydrogen equals 2 times the concentration of the full thing, H2SO4. That's remember we did that when we were thinking backwards. So you have to halve it, right? I'm going to get rid of that. Move the 2 across. So divide by 2, both sides, and we get 0.1 on 2 equals the concentration of H2SO4. So that's a full reverse. We've gone all the way back. So I guess 0.05. Yeah. Whew, there we go.
So do we have a 2 because it's 2?
Yeah, because this concentration here that we've calculated was the concentration of the total concentration of hydrogen ions, which is twice as much as the actual concentration of the acid molecule. So for one acid molecule, you can think of it like that, for one acid molecule there are 2 hydrogen ions. So for every 2 units of concentration of hydrogen ions, there's 1 unit of concentration of acid molecules. Yeah. Think about it going forwards, and then that probably makes sense, and then you can sort of see, try to work out the path backwards. Yeah. Tiffany.
Page 5.
Oh, I hope not. It should be. Oh, yeah, this one. Sorry. Oh, I think I started writing sulfuric. S. That's a 2. Yeah, I don't know what it was. It was an S. H2. All right.
That's just the string.
Anything else? Oh, same sort of thing with hydroxide? Okay, I think there's another one. Okay, we'll do... Oh, no, I've lost it. Oh, yeah, there it is. Okay, so we'll do 2B, which is a hydroxide example. 2B, NaOH, pH equals 2. So you're asking for the... Sorry, I'll write it again. NaOH concentration. All right, so again, you assume you're talking about... Oh, sorry, Jennifer. Yeah. Oh, 12, thank you. Yes, actually that wouldn't have made sense because it would have been very acidic, but thank you. So 12, so that's the pH. We're going to work backwards. Now, it's assuming that we've just got the hydrogen ions, okay, so we're working that idea of how to work. So 12 equals minus log of the hydrogen ions. Okay, we've got to turn that around and take the inverse. Inverse. What do we press? Second function. Log of minus 12. That's right, wasn't it? Yep. All right. So second function. Log of 12 minus 12 equals 1 by 10 to the minus 12. Okay, good. Is the concentration of hydrogen ions. And then we've got to work backwards to hydroxide. So OH minus equals this thing, 10 to the minus 14 over this thing now, equals 10 to the minus 14 over 10 to the minus 12. Actually, there's probably just some nice simple index laws there. 10 to the minus 14 divided by minus 12, 10 to the minus 12, so you subtract, or minus the minus. So 10 to the minus 14 plus 12, -2, good, is the concentration of hydroxide. And that, because you've got 1 for every 1, is also the same concentration, equals the concentration of hydroxide, but it also equals the concentration of the whole thing as well.
Are there multiple choices?
Yes?
Good. Same.
Yeah, there'll be a mix of multiple choice and other. All right? All good? not good.
Can we walk through what you just mentioned?
Again? Okay. So the question was, given that there has a pH of 12 and you know that it's sodium hydroxide, what's the concentration of sodium hydroxide? So pH only ever talks about hydrogen ions, okay? And so the formula for pH is pH equals minus log of the hydrogen ion. So we know the pH is 12. We don't know the concentration of hydrogen ions. So we have to undo this relationship, this formula. So we take the inverse log but I guess we really are dividing both sides by minus 1, moving the minus, okay, to minus 12, and then we're taking the inverse log of it, which is this second function thing. So we're undoing the log, and that gives us the answer of that, okay, which is the concentration of hydrogen ions, the missing part. And if you plug that back into the formula, hopefully you get back to 12. That's the way to check it. Okay, if you put 1 by 10 to the minus 12 into here and take the log and minus it, you get 12 again. But they're talking about hydroxide here, okay, so we need to convert this sort of pH measurable thing to hydroxide, and we have this relationship that helps us do that, which is the hydroxide multiplied by the hydrogen equals 10 to the minus 14. So I would jump straight in and I rearrange the formula and just divided both sides by hydrogen to get it all over on the right hand side. And then and work that out. So put the number in, and if you put it on your calculator, 10 to the minus 14 divided by 10 to the minus 12 will give you 10 to the minus 2. And that's the concentration of hydroxide, 10 to the minus 2 molar. Okay, and because this is a simple, or it's not, well, it's the equivalent of being monoprotic, I don't know if there's a word for it, but monohydroxic, there's only one, every time you have one molecule of sodium hydroxide, it breaks apart to give you one molecule or one ion of hydroxide. So the concentration is the same. If you had, 10 moles of sodium hydroxide, it would break apart to give you 10 moles of just hydroxide. There's no sort of doubling up or tripling up. It's just 1 to 1. So whatever the concentration of this is, that's what the concentration of the hydroxide is. Well, I think if you do a few examples, if you work through these worksheets, the answers are up there, so you can have a look at those on one of those earlier posts that we had, and yeah, it should be fine. And just make sure you look over those. I'll just go back to the headings. Oops, too far. Those basic groups, okay, you should be okay. Yvonne. So the question is, what in worksheet 32, question 2, calculate the number of HCl particles.
Is that what's your pH or just
now these are all separate questions, aren't they? Not related to anything. So this is just asking you to use the C equals N on V formula. Okay, you've been given, so yeah, number of moles. Someone's saying moles, that's right. When they talk about the number of particles, it's just how many moles or how many molecules of HCl are there. Okay, so number of particles then suggests to me that they actually want exact numbers. So convert the moles that you get by multiplying by Avogadro's number, yeah, to get actual individual particles. When they start saying individual particles, they're getting. Question 2 in worksheet 32. We can. It's just acid plus base gives water plus salt. It's neutralisation reaction. Okay, let's have a go at question worksheet 32, question 2. 32, question 2.
Can I keep that question?
Oh, okay, jump in.
Do you know Back to question 2.
2B. Would you say it's monoprotic?
Hey, which one are we talking about?
Back to question 2. It says determine whether
It's worksheet 31.
Yeah.
It's the equivalent of monoprotic, but it's
But it doesn't
So what do you write?
accept- It doesn't.
yeah. No, actually, I don't know. They've written that around the wrong way, I think. But it's the equivalent of just releasing one hydroxide.
So do you write just monoprotic as the answer for that? What do you write?
Because I thought you said the definition of monoprotic is when it gives a hydrogen ion.
Yes, exactly. That's what it is.
But a base accepts them.
A base. Yes. Yes. Yeah, I don't think it asks you to use those terms. Are those monoprotic and diprotic and
They're for acids.
they're for acids? And the equivalent is how many hydroxides. So the concept's the same. But we just don't really have a word. Yeah, but just understanding they can break into 1 or 2 or 3 hydroxides.
So the answer for that one, that be accepts 1.
For B, sodium hydroxide ionizes to produce 1 hydroxide ion. All right, question 32. Oh, Bell's going to go in a few minutes. So the example was how many HCl particles in 250 mils of a 0.1 molar solution, 1 molar solution. All right, so that's the question. So the thing about particles is we said eventually we're going to have to work out the individual number of particles, but to do that we'll need to work out the number of moles, because then we can just multiply by Avogadro's number and that will give us the number of particles. Okay? So we're not there yet, we haven't got the number of moles, we've just got these things that aren't moles, but they're both, interestingly, coincidentally, luckily, part of this formula that has moles in it. So we've got a volume here, and we've got a concentration here. And the relationship between those two equals C equals N on V, or specifically N equals VC. And then we just need to make sure we have everything in the right units. So we need volume in litres. So if it's in mils, we divide by 1,000. And concentration just in molar, or moles per litre, which it is, 0.1. Okay, so we work that out. Okay, so it's 250 on 1,000 multiplied by 0.1, and we get 0.025 moles. And now the number of particles is we multiply that by Avogadro's number of 6.02 by 10 where's my x one? 10 to the 23, and we get 1.5 1 by 10 to the 22 particles. Is that right? Yes. Good?
Have you got a pH or something that's been diluted?
So something's been diluted. If you want to find the pH of something that's been diluted, you need to know the concentration. So the concentration will have changed. That's the key thing. To plug into that pH formula, you need to use concentration of hydrogen ions, for example. So if you know a starting concentration of hydrogen ions, but then you've done whatever, 10-fold dilution, okay, you divide your concentration by 10, and then you put that into your pH formula. Is it too late to do question 3? We can try. The bell will only stop us. Question 3. This is still worksheet 32.
Just like Facebook right down your here and I can figure it out.
Okay, I'll give you the theory. So pH, we want to know 2 litre solution of HCl, which is dissolved. Okay, of HCl, and it's got 0.146 grams. Probably written, but that's what it is. Okay, so use these these two, okay. Oh, hang on, yeah, HCl. So this is, we're going to have to use N equals M1M, okay, to get the number of moles. So work out the molecular weight of this using our periodic table, okay, and get a molecular weight. So, well, no, go away. So, on everything, I just didn't plug it in. There we go, we're good. Okay, so that gives us the number of moles. We convert that to moles, and then we can use litres, so volume and moles, to get a concentration. Okay, moles per litre, and then where are we? We've got the pH, don't we? All right, good. So that's it. So then that gives us the concentration of hydrogen ions, and then we can work out the pH. Okay, it's minus log of whatever that is. Done. Wow, that was a bit curious. There's no answer there. It's just an approach.
Is there anything on Edmodo for this?
Yes, the answers for all these workshops I've posted a couple of posts ago at the back of one of our class notes, like about 2 lessons ago. Jenica. Yep. You'll get the data sheet like you got. So there won't be, no, you'll have to know the definition of pH. Oh, the formula. So those ones that we had at the start, you'll need to know, where are they? Oh, they're all the way back. Those, oops. So you'll need to know those formulas.
Is this going to be on Edmodo?
Yes.
Can I write a message?
I'll stop.
No, can I write a message?
You want to write a message? Okay. This. Oh, it's going to go live on video then. I'll just stop the video.